Hey, how's it going, everyone? Welcome to the stream. So I'm going to get right into this. So 2 nights ago I was continuing, or starting actually, I think, continuing work on implementing support for structs, and came to the realization that this code that I have here for creating these dynamic variables isn't going to cut it for when I need to expand a type that has more than one child. So I thought a lot about how I'm going to do this. I think I know what changes I need to make for all of this to work. So I'm just going to get cracking and see how that goes. Okay, so part of getting this to work is the realization that, what I'm going to do, okay, so I'm going to put structs aside for now. So I'm going to basically even comment out this code here. I think that's going to help me focus on what I need to do. So let's see, is that right? No, like this, yeah. Okay, so we go like this. And for indirect types, so the way I was doing it is whenever an indirect type, like whenever, let's say we have a pointer, which is an indirect type, let's say we want to display a pointer variable, just like here in my code. Let me go back. Yeah, actually, you know what I'm going to do is I'm going to move away from this and go back to the version that I have here with pointers. Exactly this one here. Let's see. Yeah. Got main, which we call foo. Perfect. What just happened? That's weird. What's it? What's it doing? Oh, that was so odd. Anyway, okay. So here we go. So this version here, and I did not mean to do that. Guess it reloaded. All right, don't know what's going on there. Control Shift B. Start building this. And there we go. So for instance, this pointer here, when we display that pointer, it's going to come in here as an indirect type. And what I've been doing, or like this is the strategy I went for before, is I would read the value address from the variable address. So this var address here, that's an input parameter. This is, let me see here. Yeah. So create that variable takes 2 parameters. It takes the variable and the address of the variable. Yeah, let's see here, up here. So for instance, when we see that pointer, we're actually going to be going through here and getting all the variables that belong to this current function stack frame. And we're going to call create that variable. So for the pointer, we come in here, we say, all right, you are a pointer. Let's read the value of this pointer to get back what the pointer points to. And then I would immediately create a child variable from that and then store that. Do I see the store here? In this thing called dynamic variables. And then I would get an identifier, a unique identifier for it. And then with that, I would store this variable's reference with the ID. So I'd already created this variable for in case the user expands the pointer, which is, if you think about it, it's somewhat wasteful. But at the same time, it's kind of nice because I actually know at this moment I have all the info I need to create it. So that's why I did this. But if we don't expand it, I've wasted a bit of time and a bit of memory, which is not the end of the world, but there is that. But more importantly is in the case of structs, I would need to create more than one child variable. But the problem is for this variable reference, which is going to be added to this, let's say the parent variable, the one that you'll see for P here, it can only have one variable reference. And so this is where I got stuck last time. I was like, well, what do I do now? Do I create, let's say, variables for all the struct, for all the struct members, but then create some kind of proxy that would allow me to retrieve all of those variables after the fact in case it gets expanded. So it's possible to do it that way, but I don't think it's the right strategy, and it would be even more wasteful, So I think that I thought about it, and I think that the right approach here is to delay the creation of this variable to the point where the user expands the struct, expands the pointer, and I would do the same thing for the struct. If the user expands the struct, then I go ahead and do the thing of at that moment creating all member variables and populating that variable for the expansion of that struct. So sorry if it's difficult to say because it's not super easy to describe, but that's sort of the idea. So in order to do that, I'm going to actually have to store more information. So in this scheme here, I create this child variable and I add this mapping here, this add variable, where I add the child variable itself and it returns an ID for it. And then later on, I take that like when we expand it, I say, okay, let's look up this ID, get back the variable and display it. Nice and simple. That's the part you'll see if I come up here. Here. So when we are getting a variables request here, if you did an expansion, we'll fall into this block here, which says, oh, my variable ref is a child variable. And in that case, get the value, the ID, go back to those dynamic variables, get and remove variable by ID. So this does a lookup, returns it, and removes the variable from there. And that's the let's say the expanded child of my pointer. So the dereferenced version of the pointer. And at this point, we are able to go ahead and create our dap variable here with that address. So that's how I did it. I'm going to change this. Like I said, now this will become a bit more complicated. The expansion of a child will actually go and create one or more variables. And the way we're going to do this is, rather than store a child variable in this array, we're going to store the parent. So let me see if I'm going to get this done first for pointers. When that works properly, then we can move on to structs and whatever else. And I think all that will finally make a lot more sense. So instead of talking about it, I think I'm just going to go ahead and code this up, and let's just see how it goes. All right, so first things first is I won't need to do this here. So we have a indirect type. All right, so we have our variable. So yeah, I think I'm just going to have to store, along with the variable now, I'm going to have to also store the address. And dynamic variables will become a bit of a misnomer here, but I think that's okay. Oh yeah, that's one thing too. This guy takes a unique pointer, which might not make much sense since, yeah, I'm creating uniques here, but let me see up here. What have I got? Oh yeah. Yeah, it gets more and more complicated. So let's see here. This var, it's a std vector of variables. So yeah. There's a problem here of lifetimes. I think I'm gonna have no choice but to go all the way up here and make this vector of variables actually store shared pointers, so that I can store shared pointers and not worry about lifetimes for these. Yeah. Okay, all right. Yeah, this is definitely going to affect a lot of stuff, but it is what it is. So let's start there then. So we start with that. So this should cause some issues where I add variables. Compilation errors there. Let's just see where this brings us. Right. So cur variables. So that's a stood vector of variable, so that too would have to change. Let me just give this a whirl. We'll see how this goes. All right. Okay, so that should be all right. Let's keep going. Right, so this var here is now shared pointers. Okay. Okay, so this is going to have to change to accept a shared pointer as well. In fact, it should probably be a... Is it a shared pointer to const? I would say so. I'm going to have to go back and do that. You know what? I'll just leave it alone. Keep it simple. We'll go back later and add const everywhere. It's not the time. Let's see here. We'll change this guy here. Good. So now we're doing that. Perfect. Yes. So this, well, this code's going to have to change anyway. Yep. Yeah. Let me actually block this all out because this is going to change fairly heavily. But now I've got that variable there. Oh yeah, these are all going to have to become var the pointer. I think this is going to build. All right, looking good, looking good. Yes. Okay, so now we've got our shared pointer, so that's good. Because the goal here now is that this variable that we have, we're going to store it in our poorly named dynamic variables here. And what we are going to store actually here is a struct of, I don't know what we're going to call this. Let's just start with that. The variable along with the memory address, the variable address. Hey Bama, how's it going? Yeah, thanks. Yeah, I thought a lot about this design, and I have a plan. We'll see. We'll see how this goes. Yep, plans are good. So let's hope it works. So here, this again is going to take a shared pointer, and it's also going to take our address. Probably a better way to do this, actually, now I think about it. I think there's a function I can use. I always forget the name of that function on unordered map. In place hint, I think. There's one where you give it the key and the value. Isn't it in place hint? Or is it try in place? Oh, that's the one. And then you give it the key. And then we say okay, like that. So this gives us back a unique ID to get back the parent variable. That's how we have to think about it. And then here, instead of returning this, yeah, that's a bit annoying. I do need both when we get this back. So either I make this little structure public, or we do like the tuple thing or the pair thing. Not sure. Yeah, let's go with making this public. We'll rename and refactor this later. But right now the goal is just to get something that makes sense. So now that I have that, what we do here is we say add our variable var along with the var address. Because basically this variable is like a static thing. That's why I was saying it should be actually a shared pointer to const. It doesn't change, you know, but its address, it depends on, you know, if, for example, if we're in a recursive function, we will see the same variable but with different addresses, which is why we do this distinction here. And since I'm going to need to later on, if we expand it, read the address of the variable to get back, say, the pointer address here, like we're doing here, this is going to be delayed. I need to have that address. So I kind of have no choice but to do that. But what this means here is all of this, almost all, okay, this is going to be moved to a new function. Now for the display value, oh yeah, that is true that we would show the address. Let me see here. Yeah. So I might have to repeat this just so that we can display the pointed to value. So we'll end up doing this twice. This is just because this is sort of that thing where I don't have to do this, you know, but it's useful to see what a pointer points to, and then when you expand it, you can see its value. We may even, yeah, I don't know. Anyway, We'll see. I mean, apart from that, what can I do? It's a pointer. I think it just makes sense to show what it points to. So yeah. All right. And we do this. We do variable reference. Here we say child variable, which is actually also not a good name anymore. Most likely what we want to say is, maybe what we actually mean here is parent variable. And we're saying this is the ID of the parent variable that we just stored here. And when we see that we're being asked for this parent variable, we're actually being asked for the expansion of it. So maybe another way to say this is a variable ref for an expansion. Expand variable. That might be another thing we could write here. So I'm going to leave it like this for now, and we'll come back to that. Oh yes, and I need to get my ID here. So okay, like that. Add this here, and then we add our variable for the current variable. So that's good. All right, so this is good. So now the next bit is this other function that we were talking about. So what's going to happen is, now that we've added the parent to dynamic variables, we go back to, let me just move this here. Okay, so this guy here, variables request. Right. Okay, so if we get this, we are expanding a variable. Get the parent variable and address. So it's basically what I had here. So I don't know why I didn't find it when I was searching for it. Anyway. Get the ID. Okay. So this is really, I'm actually going to give the name parent var here, just so that we can start tracking that and understanding that that's what we're looking at. And this, it's actually a parent parvar data. In fact, what I could do here is I can use this parvar. Let's say parent variable. I suppose I can use var. I've been using var everywhere. So parent variable along with the parvar address, like this. I think that makes sense. So this will be a shared pointer. This will be a UN16T. Very good. I like this kind of destructuring stuff. It's really nice. I can basically ignore the fact that we're returning this variable data. So I might actually make this a pair finally, or a tuple. Okay. Now comes the part where we need to create a dap variable, just like we were doing here, except instead of using that same function, we're going to call another function. Yeah, we're going to call one that's like create child dap variables or something like that, or create expand, something like that, just so that I know. Yeah, I think I'm going to call it create children, because I may have more than one, or just child dap variables. Yeah, there's the variables there, and then over here we can actually pass in the parent variable like that, and we can pass in the parent variable address. It's going to look very similar to this other function, except that in there we know that we're only being asked to do this for an expansion. And so that in that case we can add the multiple members for our struct. And then after that we're going to do this. So same thing we have here. Oh, that was from the old code before. Right. Yeah, so this is interesting. Child variables always contain an absolute address. Yeah, I guess I won't need this anymore. In fact, I probably won't need the location in the variable at all, which is going to make a lot more sense because it never really made sense. Well, no, that's not true. That's not true, what I'm saying. Yeah, that's not true. No, because I need the location for offsets, and probably I'm going to need the absolute address in some cases. I'm just thinking in my mind, like, you know, when I'm going to need to support dynamic variables that you create yourself in a watch window. And at that point, I'll probably have to, you know, store whether or not the location is relative or absolute. So yeah, that makes sense. Yeah, okay, so let's see what this looks like. We come back here. So I'm going to create a second function. Sorry. Where are we? Here. Something like that. Okay. So like I was saying, this code is going to be somewhat similar to this one. The difference is we do not expect to ever see types that are leaf node types. We only expect to see parent types. Like the parent type itself will be one that would be an inner type, you know, so like a struct or an indirect type, so something like that. So something that would have children. This will be our result. Let's copy our friend here. Okay. All right, so let's say we get an indirect type. So this is going to be now the point where we want to redo what we were doing right here. So now we can finally create our child variable. So how does this look? So we're going to say our variable will be based off of our parent variable's name. As for the value address, we're going to do the same thing here. And we're going to read from the parent variable address here. Yeah, and this disappears. Don't need that. Right? No, we don't need that. But what we do need is a add variable function similar to this one. Let me go grab that. So actually, I'm probably going to undo the changes I had made to this one to return a vector. This function here should never actually create more than one create dab variable. This will go back to being a create single dab variable, and the idea there is we're creating one per variable entry. And then if it happens to be creating one that might have children, we will, add a child reference. And then the other function gets called for the expansion, in which case we may have one or more children, like variables to create. So that's going to be another difference. So I will be sort of reverting some of the work I did to make it return more than one. All right, and then this guy, let me see here. I'm going to rename this. Let's go like this. We make a variable, do this, set its type. Now the type here, it's not this type here, is it? Oh no, it is. It is. Indirect types type. Yeah, and well, that's a type of the parent. Is this right? No, it is right. Yes, so that's it. If it's a, that's right. The indirect types type is going to be I don't remember actually. Well, this is the code I had before. I'll debug it and remember. And as for its location, yes, we set this to be an absolute address at this point. That's right. And then this guy will go through the other function here to be displayed. Or potentially this function again if it is itself, if it has children. I think this makes sense. I think so. But I'm missing a part here. What would I do for the display value of the pointed to type? I guess it's going to be this. Let me take a look again at what I had here. All right, so what was I doing? I was reading the value here, create a child variable to display the dereferenced value. So make a variable, set it to star, the parent variable's name, set its type to the indirect types type, right, and the location to be the absolute address here. And then I was saying, yeah, see, this is not for that variable. Actually, oh, I think I know what it is that I have to do here. Yeah. Okay, yes. What I need to do is I need to call, that's right, I need to call the other function. Which I'm starting to think I might want to call something else. Maybe like create the top level. I had this idea of top level and expanded. Yeah, maybe. We'll see. Does that make sense? this becomes a make shared. And then this guy returns, or right now it returns a vector, which I guess is good. No, it's not actually good. I really do need this guy to return just a single value. I have to change that. For now, I'm just going to do this. That's fine. Let's return a string vector of dab variables. Put that in there. Yeah, exactly. This guy is written in terms of the other one. I'm still thinking this location is not useful in this case, is it? Is it? Let me see. So let's say we went and this became an integer. So the type is int. We come in here. Yeah, see, I use the variable address. I don't use the location in here. We'll see. I might be right that I don't need this. I need it for stack offsets, but apart from that, yeah, I probably won't. I probably will remove this absolute one, or eventually, or keep it for later. We'll see. All right. So there we go. So we do this. Yeah, I'm going to put here to do remove. Don't think I need this. Yeah, I don't think I need it. You know what? I'm actually going to remove this. What I mean is I'm gonna comment out this line and put a to do to remove absolute might need it for watch variables later. Okay. See if this builds. It wants a oh yeah, that's right. Okay, so that builds. Now, do I have everything I need? Come here. Container. All right, let's set some breakpoints. We're going to put one in here. So this one we are going to get a pointer. I think I'm going to simplify my use case here quite a bit. Let's just do this here. Just start off nice and simple. Simple integer, simple pointer, and we set the pointer. Okay, we'll just keep it like that. We have a breakpoint in there, and we're going to have similarly a breakpoint in create child dab variables. Actually, you know what? I'm going to put it on the call itself here, and one here. So I don't need this here. Okay, how are we doing here? Built. Okay, so let's do it. I've hit a 5. Attach my debugger. Attach my debugger to my debugger. What are we doing? How are we doing here? Okay, so there we are. We're going to step into foo. We're going to hit F10, and boom, we're going to get a variables request. So we are traversing. There should be two variables, our integer and our pointer. Currently, I think we're looking at A, which is our integer. So this one here is just going to go through and do the usual thing of saying, I've got a primitive type, so I don't care about that. And we add that there. And then we go through the next one. So this guy is our pointer. Let's see, P. So here, what we should get is a indirect type. So this is where we say, add a reference to the current variable along with its address into dynamic variables, get myself a unique ID for it, which is 0. Okay, so I read here just to be able to display it. And I create a child variable with that guy, and we add our current variable here, along with that variable's reference, and we hit F5. Went here, there we go. So we've got because we added that child reference, you can see that it's got that like expansion caret or whatever you call it. And we can see that's the address that our pointer points to, which is incorrect. Why is that incorrect? Is that incorrect? That doesn't look right. Should not be in the F range, that's for sure. Weird, because that's exactly what I was doing before, wasn't it? Let me see. Yeah. Huh. Curious. Well, okay, let's just see what happens when we expand. Maybe it'll become clearer. So I go to the expansion, then here we go. We are getting another variables request. This is for the expansion. So we are expanding a variable, get the parent variable and address. So ID should be 0, it is. We've got our P as a parent variable, we got its address. And our dynamic variables, it's not empty because no, it is actually empty. Okay, good. Yeah, it's empty. Perfect. Now we go and create our child dap variable. Here we are, the parent is an indirect type. So we do again the same read. Take a look at this. Yeah, this looks like it's in the F range. This doesn't make a lot of sense. F380. Does not make sense. All right, and then we do this. Type is going to be integer, if I'm not mistaken, because it's a pointer to an int. Huh. Should be anyway. I think I've got that problem where because I'm in release, I can't actually expand it correctly, but let's just see what happens. And then now we're going to call this create here. Why is it seeing this as a primitive type? Oh no, it is a primitive type, sorry. This is the integer itself, which makes sense. But I think this address is wrong. Get some garbage. Yes, let me just hit F5 and see what we see there. Yeah, that's not right. But we're close. We're close. The logic is there. You know, the whole idea of like delaying the creation of the variable for this guy here happening later. It's got the right name, but the address is wrong, and the value, of course, is incorrect. Funny though that it says 126. It's really strangely close to 127 of all the values. All right, so let's see if we can understand why it's doing that. So let me run through this again. Okay, F5, F6. Okay, not the first one. Let's go for the second one. So here we've got P again. This oh, maybe this is why. Okay, I've got the stack location here. This hasn't changed though, so this should be correct. Oh, there we go, CBE4, that is correct. So what happened to that value? Maybe I'm not storing it correctly. Let's see. CBE4, CBE4. So that would be the location of my pointer in memory. That's correct. Hey, how's it going, Dinnerin? So why a debugger? This is related to your Vectrex emulator. It is actually related to my Vectrex emulator. Basically, the idea here is that you can write C or C++ programs, games for the Vectrex using this fork of GCC. So this here is like some code that compiles for the Vectrex. That works. There's been a fork of GCC that targets the 6809, and that works fine. The only thing is that there's just no way to debug it. So, you know, in the spirit of improving debugging tools, I was like, oh, it would be nice to be able to debug this stuff. The thing is that, you know, GCC normally, the way you do that is you pass -G to tell it to generate debug info. And what that normally does, like at least in modern times, is you'll compile and get an ELF, and usually you'll embed dwarf, which is like the debug information, into that ELF file, or you could have it externally, and GDB would know how to parse this like dwarf format. The thing is that this GCC fork does not emit ELF or dwarf. It emits this binary blob that, you know, you just upload to the Vectrex, and as for debug info, it emits this, like it emits this format called stabs, or a stab here. You can see it here, which is symbol table strings, I think. Yeah, and it's what it does is that the listing file that describes, you know, the assembly code is interspersed with this like textual stabs information, and that's basically your debug info in text form. So, you know, this is an old format, like really old, and some tools know how to parse this. GDB doesn't, unfortunately. So I thought, well, I could parse it. I could parse it, build my own, you know, symbol, like my own database of debug information, and then I could implement this protocol called DAP, the Debug Adapter Protocol, and it's something that VS Code, Visual Studio, Vim, Emacs, and a few other editors support now, and probably more will support. And it's kind of like generic debug adapter, like debug interface. And so I'm implementing it in Vectrex, in my emulator, so that like when you say I want to debug this ROM, it launches my emulator and it starts talking, like VS Code will talk to my emulator, and as my emulator is executing instructions, it can do this thing where, you know, you set breakpoints, you can step, and it'll execute the correct number of instructions for stepping a line of code. It'll display variables, all that kind of stuff. So that's where this whole debugger thing fits into the Vectrex emulator. So in effect, I'm building probably the only C++ debugger for Vectrex through my emulator. Although I might be wrong, maybe someone else has done something similar, but I haven't seen anything to that effect. Hey, no problem. It turns out that if you look it up there, the Vectrex homebrew scene is actually quite active. It's like surprisingly active. Like I'm part of this group on it's like a Facebook group for Vectrex fans, and they like people on there. There's a bunch of people who are creating games for the Vectrex, homebrew games. They even like make, because you know how the Vectrex has this really you have the cartridge, and then you have the what do you call it, the overlay. It's like that plastic overlay there. So they'll make custom overlays. They'll actually print cartridges with PCBs and burn the ROMs and sell them. Some people open source them. So yeah, it's a quite a thriving and healthy community of games. There's way more homebrew than there actually are original carts for the Vectrex. So it's pretty cool. So I think somebody in there might find this useful. I'm actually hoping to use my own tooling to try to make a game for it myself. But we'll see if I get to that. Yeah, that's true. That's a good point. But I was surprised because, the Vectrex is quite niche or niche. But yeah, people love it. And it is because it's fun. It's fun to write stuff for it. It's a very limited system, right? You don't have a lot of memory. You don't have a lot of time. But it's like, it's so simple because it's black and white. You don't have any colors, right? The color comes from the overlay. All you got to do is program the movement of a beam. In some way, it kind of reminds me of Logo. Logo, the turtle thing there, where you would like pen up, pen down, sort of rotate and move forward, and you could like draw lines. It was just a simple line drawing tool. The Vectrex kind of like that, right? You've got this beam and you're moving around and you're turning on the beam, turning it off. You have a little bit of control. You can set the intensity of the beam. And in fact, it's interesting. Like you can actually make a line brighter or darker based on how fast you make the beam move, depending on like how much of a distance you give. There's a lot of interesting things there. Very analog. But yeah, it's kind of a fun system to write games for. So you got to think a little bit differently. It's definitely not a raster. You're not thinking of it in terms of drawing pixels. You're really thinking of it in terms of drawing lines. So I think a lot of people like that simplicity. Yeah, actually, it just came to me. I was just thinking about how, moving the beam around kind of reminded me of Logo. Logo is pretty much my first... when I was a kid, that was my introduction to programming, I suppose. I was in grade school, in primary school, and I think it was grade 4 or 5. I did a lot of Logo in our computer lab, where I think we were one of the few schools who had one. And yeah, I didn't call it programming. Nobody told me it was programming, but in retrospect, that was pretty much my first experience. Yeah, so I'm a bit confused about what's going on here. I don't understand. Let me see here. So I've got variables. Each variable has a location. Let's see here. Bama, you're saying your debugger will help people to dev new games on the original Vectrex. If someone makes a hardware update, a FPGA implemented running at more than 1.5 megahertz, any aspects in the debugging if the frequency is much higher. I'm not sure I'm following what was your last, what you meant in your last sentence. Oh, you're asking me? Are you asking debugging if the frequencies? Not really. I mean, you know, like this debugger is not gonna work with an FPGA unless someone was to like, you know, unless there was a debug interface to the FPGA and from which I could read all the information I have here, which is like being able to tell it to step an instruction and to read from the memory bus. If I could do all that, then yeah, I suppose, rather than use my current CPU and memory bus implementation. But if I remember, this is limitation the number of cycles per screen refresh. Yes, that is true. And in fact, I think there are some people that have done some experimentation with trying faster processors, but you have to basically, or not processors, changing the clock. So someone has modified the clock, and of course, along with the clock, you have to change a few other chips because some chips just won't work correctly at higher clock rates. So probably the 6809 is one of them. I think you can put a faster one, and I think there's a couple of other chips. So there is someone out there who's been experimenting with that. There's like I think I saw some YouTube videos where some guy like opened up his Vectrex and changed the crystal, the clock in there, and then changed a couple of chips and was actually able to make it faster. And what was interesting is it works. The Vectrex is surprisingly resilient to going faster. And what ends up actually happening is, at least without any tweaks, the display, it ends up rendering smaller. Do you know what I mean? Like it's scaled down, what it renders. Which is really interesting. It's because in the end, it's all about timing, right? You move the beam, and then you turn on the beam and you move it again. So when you think about it, if the clock is faster, then then it's going to try to. The beam doesn't move faster, but when the CPU tells it to turn on, tells it to move, and tells it to stop, is going to happen faster at a higher rate. And so the beam doesn't get as much time to travel, say, as it would have at a slower CPU rate. Does that make sense? Well, what I'm talking about is not about the decay. It's really about think of it as two separate components, right? You've got let's say the screen, the beam, and then you've got the CPU, and the CPU is executing instructions, and it's basically telling the beam, okay, at this moment, at time t, 0, start moving, and then at t1 it says, okay, stop, and in between it, and of course it turned on the beam. Now, if the time between t0 and t1 is smaller because your CPU is faster, you end up with a shorter line. Exactly, yeah, Dineren, you understand what I mean. I should try to find that YouTube video. It's really quite interesting. So, if in fact, I suppose I would see that effect myself in my emulator. I haven't tried it, but if I was to raise the clock rate, I suspect that's what I would see. I would see the rendering, what I render gets smaller and smaller. It should get scaled down. Everything will be scaled down around the center. That's another interesting thing, because the Vectrex, its center, its 0, 0 really is the center of the screen, and everything always starts off by, like every frame, if you will, has to center the beam, like reset everything, and then start drawing from the center. So it actually does scale exactly as you would expect. It scales into the center of the screen. It's not like the center is in the upper left corner, you know what I mean? In which case scaling would happen in that direction. Okay, so what the hell is going on here? Yeah, the resolution is technically small, yeah. If you can call it a resolution. All it is that it comes down to the fact that it's an 8-bit processor, really, right? It's 16-bit addressable, but 1 byte per address. And what they did is, to abstract the space, to make things fast on an 8-bit machine, they decided to just use 1 byte for X and 1 byte for Y. So basically, you have from minus 128 to 127 in both directions. But you do understand, right, that those are not absolute positions, right? These are just relative positions. You know what I mean? They're not even positions. They're like, I guess you can think of them as values that drive the speed of the motor. That drive the speed of the, what do you call it? The thing that moves the beam, the integrator. So that's the resolution you have in terms of like control. But you have other things you can control. You can actually control the speed of the beam. They call it the scale. So you have another thing that sort of adds to the effect. So if you set the scale high, a small movement in X is going to be larger than if you set the scale low. So it's really quite it can actually be quite mind-bending when you're trying to code for it. Usually, though, what you do is you don't think too much about it. You get yourself into like a fixed scale that's good enough. You try not to make the scale too small because you'll have to waste more cycles moving your beam. But you also don't want to make it too big so that you get enough precision for so that 1 unit gives you not too long a line, so that you can draw your shapes. And once you found that sort of that sweet spot for your game, then you just think of it as, you can almost think of it as drawing on a grid. So this address here, this is definitely on the stack, but why is it that when I read now from it, I'm getting back this address that I do not expect? What is going on here? Okay, let me take a look here. Scope, variables. I've got 2. I've got A here. I've got P here. Now A, that's the thing, I can't see its location here, can I? Well, I guess it depends how you see it, See, I'm happy that I got to experience this kind of thing, but everyone, our people older than us will be like, oh, it was so cool to experience, I don't know, the early pinball machines or whatever, or the mechanical pinball machines. We all have our own nostalgia lenses, I suppose. Right. Okay, so this is at stack offset 1, and this guy should be at stack offset 2. Where is it? Yeah, stack offset 2. So now come back into here. My stack address CBE2. So A should be at CBE2 plus 1. So CBE3. So let's see. A should be this. Wait. Hold on a sec. Did I step enough so that... Oh, I'm such an idiot. I think I bet you this is all working. I just didn't step far enough. There we go. Okay. That's all I needed. You see? Okay, perfect. Okay, so it actually works. I was debugging for no reason. This actually does the thing that I expect it to do. Let me just add one more. Okay, in fact, let's just put all this back here. This should all work. Yeah, it's doesn't happen all the time where you think you have a bug and it's actually working correctly. Usually it goes the other way around. Yeah, but I mean, you can totally check out those videos. I know that it's not easy to figure out which videos to watch. So this has been on my mind for a while now. It's like on my to-do list. I would really love to. It's gonna be a big thing, but to go back through all my YouTube videos of this Vectrex development, and we're talking like, this is what. What's this? 125? How many videos have I made? A lot. And basically go back and like make a list of each episode and basically what the episode covers. And a kind of very quick description. I mean, I already have descriptions on each video, so that's going to be helpful, but I sort of changed my style of what I write in the descriptions. But effectively, I want to have like, big table, all the episodes, what I'm covering in there, and then I sort of want to group episodes. Like, this is a set of episodes I'm working on the CLI debugger, and this set is where I started doing, the implementing the graphics pipeline, and then eventually, obviously the debugger, all that stuff. These are the 16 episodes where I was debugging that stupid Bedlam bug. I don't know if it was 16, but it certainly was a lot. And then this way, is actually, if you want to see what you just said now, I want to see how did he implement that CRT display, you could find it more easily than trying to look through my descriptions. Yeah, I mean, like I said, I don't think a tool like that is going to help me very much. I talk a lot. Yeah, I don't know. I think I'm gonna have to base it mainly on my own descriptions and watching a little bit of each video. Right? It's gonna be long, but I think it'll be worth it. The funny thing is that I haven't gone back and watched my early videos, but I know those early videos were not the best. I was new to all this streaming and programming on stream, and I remember being really nervous about it too. And the quality, I think I had a crappy camera. I didn't have a good mic. So there were times where I would listen back and it was like you could only hear my keyboard and anyway. But still, some people like that. Yeah, COVID time. Honestly, to me, COVID time means less time, not more. I don't know about you there, but I don't know. It just feels like there's a big time warp, and somehow I end up with less time than more, despite the fact that I'm not traveling anymore to work. Oh, no, thanks for hanging out, Dinnerin. I'm happy to answer any questions. Hey, thanks for the subscribe, man. Appreciate it. Okay, so did I actually debug this yet? No, I don't think so. Let's check this out. So let's see if this works. Oh, okay, yeah, that looks good. That looks great. Very nice. Very cool. So let's step inside recursively. Let me go like halfway here. Just have some garbage in there. Oh, 0 initialized, no kidding. And if I click up here, yep. That looks great. Let's go one more. Let's go for another one here. Excuse me. R3 looks good. 6, 14, 14, all different addresses. Okay, cool. So this is working. I'm satisfied with that. Okay, so now with what I have, and I definitely need to clean this up, but let's because I'm kind of excited to see this. Let's try and add the struct thing, because that's sort of the goal of all this, and then we'll clean it all up. All right. So I've got my indirect type here. Now let's do the struct type. So for struct, when we are creating this at this level, I will not actually go through all the members. Instead, what we want to do is going to be somewhat similar to here. In fact, it's going to be practically, yeah, not quite the same, but very close. So we're going to add the current struct variable. For display purposes, we do not need to read any address. But what we do need is, let's see, variable reference. We're going to do this like that. And then we're going to do an add variable, which is this variable name. Display value, I guess I don't really know what to show here yet. Yeah, I had some code for that. Here, let's do that here. This. For the type, we want to show the name of the struct. And the variable reference. Like that. Okay, so that adds the top level, and then when we expand it, we add this case down here. Okay, like this. Okay, so now we are expanding a struct type. So this time we will go through the members and we can go ahead and create variables for each. We will make shared. We will copy our member's name and type. Yeah, see again, I don't need this location. What we will do instead though is we will compute the member address from the parent variable address plus the offset. We do not do this. Okay, and then we will do something very similar to this here. And I will also rename this to var. Let's see. Member address. I was just thinking maybe I'll rename this here to, in the spirit of calling this a member address, I'll call this the pointee address. Pointee, what the pointer points to. Yeah, so I think that's it. I think this should give us struct expansion. So let's see. So of course we're going to need some code with a struct. Let's enable the code down here. Let's go. Let's go like this. So here we got f. Now if I expand it, it has, yeah, it's got all the members. Very nice. Of course it contained garbage, but that's expected. And we put 12 and we put 34, and I'm going to add some more setting of values now. In fact, I should be able to set all the values even this way, right? So let's say we put 1, false. That's funny, because I was actually writing an integer value into a bool. That's nice. For weekday, we'll say I don't know, Monday. For this, now of course this bit field is not going to work yet because I have not correctly implemented that, but we will. So for now, I'm just going to put, like, I don't know, 2 and 3. And then we'll just change values here. So this becomes true. F.C, we'll make this Wednesday. F.D 4 and F.E 5. Overflow, yeah, okay. Let's see here, 202. What's our problem here? Yeah, I guess I can't do this kind of initialization on a type that is. Can I do it this way? Missing, yeah. So I guess can you do member initialization for types? Oh, is it because 3? Oh yeah, 3 is too big. Okay, this is only 2 bits, right? Still, overflow in implicit constant conversion. For which guy? Oh, down here. Is that? It's funny that this is actually an error. 207. Yeah, there it is. Okay. I can only put 0 or 1 in there. It's a 2-bit value. Okay, there we go. Perfect. Hit F5. Let's see. So right now, F should contain garbage, and then I'm going to initialize all members. Boom. So obviously this is wrong. That's fine. I haven't done the bit field support just yet. But this is right. This is a float. This is a bool. This is a weekday. And these are considered ints right now. 12, true, Wednesday, and whatever. Totally incorrect there. But yeah, this is pretty awesome. Very happy with that. Very happy. So now I'm going to do some cleanup because this was hacked in very nicely. So let's finish up this cleanup. So first things first, I'm going to go back and change my. Right, so then I don't have to have an add variable in this function. This one here we'll go back to returning a single dap variable. I don't even know if I should have this anymore at this point. Not super useful, but just for now, let's do it like this. And then this becomes return make that variable. I don't think I mind that too much. I'm going to add that else branch here for the unknown, just like I did here. Why not? This shouldn't be called for unexpected types anyway. Okay, so this now returns a single dap variable. So now down here, we're going to change this to create dap variable without the indexing at the end. And as I suspected, I did not need to create this var with location. So this makes me think then that I'm going to have, so if I'm going to keep this idea of having a stack offset, and then eventually an absolute offset, I want a type that represents no location, just so that I don't accidentally do anything with it. And I suppose this should be anything. So right now, absolute address is not even being used. So technically, I think we should just remove it. Is that true? I think so. Since I'm carrying the address of the parent type and I'm able to compute from it, not all control paths. Oh yeah, right. So we should never reach the bottom based on the way I did this. And I think that's fine, having each one of these cases return. So yeah, if we reach here, just do that. I should add like an unreachable macro. To signify that this is unreachable. And let me kill this. This should build. Yeah. So I'm looking for absolute address. So yeah, I'll add it back later when I actually need it. I don't want to hang on to something that's not used. So that's good. Yeah, so see here, I should be able to do this correctly. I will need to, for now, what I write here, this doesn't make sense anymore. For now, I say store struct address plus byte offset to each member to do add support for bit fields. So for now, only what would it take actually? Let me just think for a second. I guess what it would mean here is when I do create dap variable, I would need to add another parameter, which is the size of I either pass it in as a address. I could do that. I could do the number of bits or the size in bits. I don't know. Alternatively, it could be a member of variable. Does that make sense? It sort of makes sense, I guess. A variable has a name, it has a type, like integer, but the number of sub bits, or the offset and the number of bits there, is like sort of like a view that this variable has at a specific address for that given type. Yeah, bit fields are weird, honestly. They're just weird. Okay, so we'll come back to bit fields. It's obviously not something I can just hammer in there. So let me do this. So for now, or I'll just do this, add support for bit fields. There we go. Yeah, I like how this is turning out. It's pretty clean, actually. And then this here will be also called, okay, let me just do this. I like the symmetry of all this. That basically this create dap variable. If it's a leaf type, a primitive type, it just goes ahead and creates it and we're done. But if it's any other type, like, or I guess enum type is also a leaf. But if it's a inner type, like a struct or an indirect, which is basically a pointer or a reference, it's going to go ahead and create a variables reference. And that's the field, you know, that when you add that, it tells the debug adapter or the debugger, this type, like this variable can be expanded. And the value we store in the variables reference, so this ID, this is the thing that we're going to get back. You know, actually we're going to get back this whole thing. And from there, I'll be able to tell that we're looking for a child variable, which maybe I need to change this. Again, I don't think this is a good name for this anymore. But yeah, with that, call stack index child variable. It's actually not the child variable, it's the parent variable. That's what we're storing in there. You see? I think that's what we're gonna have to put in there. See, yeah, when we come here, we even see it. We're getting the parent variable and its address. So let me do that. And just give me a sec. I call this call stack index because it is actually a call stack index. So maybe it's parent variable ID. Yeah. Yeah, see, I like this. This all makes sense. When we are creating a dap variable, say for a pointer, we come through here and we say, okay, you are a pointer, over here, indirect type or struct, whatever. And we create a variables reference that says, this is a parent variable ID. This is ID that we added up here. So maybe I'll put these closer together. They go like this. Yeah. So display ID, we get an ID in dynamic variables. This is perhaps the misnomer here, but that's okay. I guess it isn't actually adding a variable, so that's okay. Then we go and we say this is a parent ID, there's the ID, create our dap variable. Then later on, when you expand it, we're going to get another request. And when we get our variable ref here from the request, we're going to take a look at it, and it's not going to be a call stack index, it's going to be a parent variable ID. So we know, oh, okay, this is a parent variable ID, so therefore we are expanding it. So we go ahead and use that ID, we extract the ID from this variable reference, we get the variable back, the parent variable, along with its address, and we create a child dap variable from it. So this is the special function that's used to create children variables, one or more. And in here, so far we only have structs and indirect types. Speaking of which, I think struct here might need to be renamed, but I don't know. No, I think it's okay. Yeah, I was gonna say structured type, but no. We can't differentiate classes and structs right now, so I'll just call it a struct. We'll see. I'm thinking that maybe I'll eventually have to figure out, or would like to figure out, if a type is a class or not. I might be able to know. I will at least, I think, be able to know if a class has a vtable, and in that case, Oh, but that actually doesn't make a difference. It's really more about displaying it to the user. If the user typed class or typed struct, it would be nice to show that in the debugger. I might have to literally parse source for that, which is a bit annoying, but it'll just enrich the debug info because I don't actually have that information in the debug information that's provided by stabs. So yeah. So there was another thing I wanted to do, which was the destructuring. Let me go back to here. So this should all build. Yeah, I'm gonna change this. Actually, I'm going to keep it like this internally. There's no need to do that. But externally, you know what? I think I'm just going to leave it alone. It's fine. It's fine. This is perfectly legit. Let's leave this alone. I will make a note though here. So I'm just going to give myself a little comment to remember. This is used to store store variables that can So one thing about this is there one thing about this? Yeah. So one thing is that if we don't expand, then then this just keeps growing. I need to do some kind of flushing of this, like clearing of this cache or whatever. When these variables are added along with their address, we return a unique ID that can be used to retrieve the pair if that variable is expanded. Excuse me. Yeah, so basically what I was saying is that this is cool, right? Like it works, but one thing that sucks about it is, you know, we go ahead and only remove from it when we expand. You can see that in here. If we never expand, then this guy just keeps getting things added to, and eventually it'll just have a whole bunch of variables in there. So since I'm only using it, I mean, I guess what I could do, I was thinking about this, maybe if we get a call stack index, I could clear it in here. Because the idea there is that every time you click on a new call stack frame or you enter a new call stack frame, we're going to get like the debugger is going to clear everything and then say, okay, get me a, it's going to send a request for those call stack variables. And that comes from this here. There's going to be a scopes request. So every time we enter a new scope, and in this case, scope it really means a call stack scope. So we click on a new call stack or we enter a new call stack, there's going to be a scopes request. So at that point, we say, okay, we're going to go and create this call stack index thing, and then variables are going to be requested for it. So when we're doing this, we're effectively populating the variables window, from a clean slate. So this would be, I guess, a good place for me to clear this cache. Let me show that that's actually the case. So we have no breakpoints. No, we're building here. Let me put a breakpoint in the call stack index here. I do need code that actually calls a function. So let's make a function, I guess. Good old foo. Like this. All right. I keep doing this. Can I call it foo? Because I have a foo in my dummy header file. Okay, you know what? Let's call it something else. There we go. Now I can call this foo. Because that's what we call dummy functions. So let's attach ourselves to Vectrex. So we go in. So here's our first call stack index call. Let me clear my things there, and we're going to put here dynamic variables. So here we can see, of course, the size is 0. That's to be expected. We'll hit a 5. We step in. Once again, we get called. I hit F5. So now we should have, I guess, 1 value in there. Now if I click on the main stack here and then back into foo, I guess it's smart enough to know it's got nothing to do, and probably because main had no variables. So let's add some variables here. Okay, let's try that. Because what I'm expecting is I need to make sure that when I click the different call stacks that it wants to make requests over and over again. So we'll see. Another call stack index. So every time I step, even if I'm in the same one, I get one of these. Does that make sense? Okay, so it's not exact. It doesn't behave exactly as I figured. So that's it. I cannot then clear it. I would have to clear it, I suppose, if I detect that the call stack index changed. I actually think I had done this already, and then I removed it. But I think that's what oh yeah, that was for something else, but it's going to be very similar. I would have to detect, I think. on the other hand, I guess I could clear it every time. I mean, fact is, if I'm getting this called over and over again for the same call stack index, it means I'm repopulating everything all over again. Oh wait, what just happened there? That was surprising. Oh, okay, it's because I didn't have a breakpoint inside here. Yeah, see, I keep redoing this. I keep going over all the variables. So yeah, I suppose I could clear it every time. I think that would work. Okay, so let me just see if I was right. If I step into foo here, okay, so there, I think now I'm finally going to add, there we go. So we now actually have a 1 in our dynamic entry here. If I click here, there we go. See, now if I click on the parent, because there are variables here, we're going to get a call stack index call, and you can see it says size 1 here, right? I'll hit F5, I'll remove this here. And now I'll just kind of toggle back and forth. In fact, what I'll do is I'll remove this breakpoint. And this is what I mean. I'll effectively be just kind of leaking, not really leaking, but using up memory without ever clearing it. So in effect, it's a leak. If I never clear it, it would be a leak, right? So let's go here. Huh, this time it doesn't hit my breakpoint. Is it smart enough? Anyway, I'll hit F10 now. Oh, okay, so it didn't. That's so weird. What weird behavior. But I guess if I keep stepping and it keeps getting called, there we go, 2. So okay, so that's the leak right there. Every time I step there, 1, 2, 3, 4, 5, you know, I'll put a breakpoint back here, I'll step again, and there we go, we've got 6. And I mean, all of these are the same, actually. These all refer to, you can see it here, variable f, that's struct. But in fact, the only one that would actually be used is the last one, because that's the last one we added. And if we were to expand, it would expand number 5. So see, now all of these here are here, but I'll never expand them. So I think then, based on what I've seen, it would make sense for us to clear this. Let me add a clear in here. Okay, so let me put a little comment here. We are expanding a variable, get the parent variable address. We're about to populate variables, top level variables for the current call stack index. So clear the dynamic variable cache. It really is a cache. Well, is it a cache? It's not really a cache, but it's sort of a cache. Like this. Let's make sure this works. Just gonna make it recursive. Let's get in there. Oh, wait a minute. This did not build correctly. Oh, okay. Never mind. Okay. It's so cool to see it work. I can't see parameters yet, like count. That'll come. Very good. Okay, so yeah, this looks good. Let me step out, and there we go. No crashes. Everything looks like it's behaving normally. So I think this is great. Append values. Source to target. Yeah, sorry, I'm a little quiet there. Just want to run through all this and make sure it all makes sense. I think it does. Let me go look at my diffs here. I think this is not necessary. I think I added this as a, yeah, that's not necessary. Let me go to my debug symbols here. Yeah, it's not used at all. Okay. Oh yes, lots of work we did in here for being able to extract our struct info. Okay, yeah, this looks good. So let's stage all this, except for these guys. Support displaying structs. Actually, you know, one thing I did not try, but should work, is embedding a struct in a struct and seeing how that expands. I should try that. So yeah, let me try that. Hopefully it'll work, and then I'll stop here. And if it doesn't work, I'll probably not stop because it'll drive me crazy. So let's start with something simple. We've got, oh yeah, and I can't initialize foo this way anymore. You know what I should do is I should do this, the constructor. So bar I'll just leave alone. D and whatever. Like this. Okay. Let's test this out. So here we are. So here is our F with a bunch of garbage. Constructor gets called and it's all nicely initialized. And look, it's got a bar. And bar has values. Holy crap. So there you go. It totally works. I should, okay, just to be sure, and I'm, you know, whatever. It's gonna work fine there, but we'll just set some values in here. Here we go, 4, 5, and 6. Sweet. So yeah, it looks like we're in business here. All right, so I think guys, this is great. Really happy with this progress. Obviously, there's still a lot to do, even for structs. I have a whole list here of things that are not yet working in structs, structs, classes, whatever. You know, support for pointers. So right now I'm not parsing the pointers in a struct correctly. So I'm going to work on that. Support for bit fields, as we talked about. So that needs to be put in there. I'm not really sure what vtable means yet in terms of support. I would like to take a look at that once we start adding virtual functions. Related to that is this pointer. This will have more to do with when we debug member access in member functions, like data members, and what that looks like. And then yes, and adding support for self-referential types. So pointers the same type, you know, like kind of like linked lists. And then I said this may really be related to supporting forward declarations, which I have up here. So I know this doesn't work. Yeah. So there you go. So lots of stuff to do, but this is really cool, very promising. Yeah, and then after that, we'll do unions, right? Let's see here. Unions is going to be very similar to structs and classes. The only difference with the union is that all the expanded variables of the union are going to be all evaluated using the same address. You know, so where members of a struct, each member has its own offset. In a union, they don't have a different offset. They all have the same offset in memory. Each member of the union. The only difference is that each one has its own size. So I just had this thought. Are bit fields supported in unions? Does that even make sense? I don't know. Not unions in Quebec. Let's see, bit fields in unions. Yeah, it looks like you can. It's perfectly valid C. It is valid, but as you find out, not useful the way you have done it there. You might do something like this, so you can reset all the bits at the same time using flags. Right, okay, sure. But this is not what we're talking about. This is a struct inside a union. This is more what I was wondering about. So yeah, this is not answering what I thought. But yeah, it does sound like you can do it. So yeah, I'll have to take, I've never done it before, but I suppose somebody would do it. And this is why it's so hard to write a C++ debugger or even a C debugger. There's just so many corners of the language. You know, when you program in it, you can decide whether or not to use those corners. But if you're writing a compiler or a debugger, you gotta support all of it, right? I mean, I suppose for a debugger, you can decide what subset you want to support and not support the rest. But somebody along the way will say, "Hey, this is not displaying my stuff properly." All right, so guys, this is where I'm gonna sign off. We'll continue next week. So thanks a lot for watching, and I'll see you next time.